Hi everyone, in this video I want to talk about graphing stretches and compressions of parent functions. This video is meant to come after you watching the graphing shifts and reflections. So here are the two problems that we'll do, and to make sure that we don't take ourselves too seriously, let's think about the fun question. If you could own any animal tomorrow, which would you pick? So under Algebra 2, is where transformations will fall. So this would be like the second round of learning functions, and we are transforming graphs. So in this video, it's taking one of the parent functions and stretching or compressing it. Notice under geometry, we also have transformations. So that would be doing like a dilation would be the equivalent of this lesson, but with a shape. So like a triangle or typically just triangle. Okay. So in the other video, I did talk about the parent functions. They are the foundation of all of the other functions that you see here. That would be, a compression or a stretch from basic 5. So in our examples, we have a cubic function and a quadratic. So the cubic function we know is going to be, it's going to look like the snake. It goes up and down. 0, 0, 1, 1, 2, 8. Those are the points that we use to graph one part of just the x cubed. So that's 0, 0, 1, 2. If you plug a 2 into x cubed, it'll. So we know that that part of the graph. The other is symmetric about the origin. So like across the 0, 0 is where the other part of it shows up. So 2x to the third, there's just x to the third. But 2x to the third, what's going to happen here is we're going to multiply all of this by 2. What a lot of people think is that these graphs will become basically fatter, wider versions of themselves. But you end up getting 0, 2, and then 16 with those 0, 1, and 2. So it's going to be then 0, 0, 1, 2, and then 2 and 16 is way up here. So, whatever you do on one side, this graph is symmetric. So we are going to do down here, that would be then over 1 down 2, over 2 down. So this graph actually gets skinnier. It actually gets skinnier. So we call that, it's all in relation to vertical stretches and vertical compressions. So stretching something would be like pulling it up and down, making it skinny. Vertical compression then would be like imagining your hands pressing down on something and it gets wider. So this we would call a stretch. And then this 1/2 is going to have the opposite effect, where we actually have a compression on a quadratic graph. So I'm going to do the same thing. We have just an x squared graph, right? So x and x squared, that's 0, 0, 1, 1, 2, 4. I need to shift this graph first. So rather than doing 0, 0, let's just do, graph it as if it was this function here. So that means right 4 and then down 1 would be the new vertex. And then from there, I'll do the 1/2. So if I'm going to do times 1/2, we'll keep the same color scheme to be consistent. Times 1/2 times 1/2 times 1/2 to everything. Okay, so we get 0, we get 1/2, and we get 2. So that means that my graph is actually going to get, here, we'll do the blue, the original. The original would be like 0, 0, 1, 1, 1, 1, 2, 4, 2, 4. So that's the original, right? Shifted, of course, but then we'll do 0, 0, 1, and 1/2. Okay, so I'm going over 1 and up 1/2, up 1/2 the other way too. And then 2 from here, 2, 2, from here, 2. So this graph getting wider. And so this will actually press, meaning like imagining your hands coming in, from the top and the bottom to press down on that blue parabola to then get the red one. Okay, so why don't you try a few practice problems? These two are both stretches. You can see because, and how do you know? Well, this number here, if this A term is greater than 1, you'll have a stretch. If it's a number between 0 and 1, then you would have a compression. So a vertical compression. So try these. And note if this was 1/4, that would have the opposite effect on the graph. Why don't you pause the video, try these, and then I'll review the answers. Okay, answers are here. So the vertex shifts for both of these. And this, think of it like a slope. This slope would then be 3/1 because that A term is 3. And then this also gets stretched significantly because that A factor is now 4, right? So that's why all of a sudden these numbers are starting to jump up pretty quickly, because if everything is getting multiplied by a 4, it gets steeper. Okay, quote to leave you some inspiration. Leadership is the capacity to translate vision into reality. So I hope this video helped you in some way, and feel free to leave your answer to the fun question in the comments. And if you'd like to keep up with new videos, subscribe. Thank you.